Well, good morning everyone. This is KP the Math G. Excuse me. We're talking about the 2024 free response question number 6. This is part C of the question. Remember from my last video, we answered parts A and B. And I don't have that paper. I do have that paper with me. We had to, if you go back to my previous video, we would have to plot a slope field and then describe all points in the XY plane for which the slopes are positive. So those were the first two questions. This one is probably something you're more familiar with, and that is separation of variables. And that's what we're going to do in this video here. We're going to separate the variables. Well, let's go ahead. It says find a particular solution, y equals f at x, where the initial condition f at 0 is 3. So we're calling this function f, and we need that initial condition f at 0 equals 3. We have to be able to separate the variables, so let's do that. Let me erase this word given, and well, I don't know, we'll leave it up there. Okay, so let's see, I want to get rid of this dx here. I want to do that, and it doesn't matter what order you do this in, everybody, but I always like to get rid of my denominator if possible. So if I will, I'm just going to write with this dy over dx. I'm going to multiply by dx, and that's equal to x squared y minus 1 times dx. Well, we see that these two go together, and this is the only thing standing in the way of getting this completed. Let's go with this. This is dy now. Dy is equal to x squared times y minus 1 dx. All of this is multiplied, so we're going to divide by y minus 1. Treat that as one quantity. Y minus 1, y minus 1. Alright, so what we have here is dy over y minus 1 is equal to x squared dx. Alright, that's where we are. We need to be able, the variables have been separated. I'm pretty sure you will get a point if you're able to separate the variables. Let me see if I can find the scoring on that. Not sure if I can or not, but I'm going to look for it. Let's see. Yeah, separates variables. You do get 1 point for that. Alright, now we're going to set up antiderivatives. Okay, so here we go. Like this. Once you separate it, you have two problems to work. One on one side of the equation, one on the other side of the equation. Well, alright, then let's solve this. Now remember, there is an integration that has this, you know, like if I had something like du over u, that is ln of u plus c. If you have an exponent of 1, you can simply do that, and we can let u be y minus 1. We don't have to, because really I know that the derivative of y minus 1 is just 1. If it had been negative y, then we would have a negative sign to go with that, or 2y or something like that. We would have to deal with it that way. But if you have a y minus 1 or y to the first power in your denominator, this is an ln. Definitely an ln. Now if you have y squared down here, it is not ln. Now don't get that mixed up. Okay, this is an ln. So if I did let u be equal to y minus 1, then du is equal to dy. And what we would have is du over u, which is ln of u, alright, plus c of course, but u is y minus 1, so ln of y minus 1, using the absolute value bars for this, but I think it's safe to not have them, and I studied the reason why it's safe not to have them. As long as your y value is not negative, you don't need that, okay? So that's what I'm thinking here. Alright, I want to say this is, maybe I'm confusing that with another, but well, f at 0 is equal to 3. Yeah, there it is. 3 is the y. So you do not need the absolute value bars. You can just simply use parentheses. There it is. You're looking for your y value here. X is here, y is here. Your y is positive. You're not going to need the absolute value bars. Alright, that's the left side, ln of y minus 1. So let's go ahead and flip this over so I can have some room to work. Alright, so bear with me. Alright, x squared dx, okay. Yeah. So what we had, guys and girls, is we integrated dy over y minus 1 is equal to x squared dx. This is easy here. But to say this is equal to ln of y minus 1. Now remember, the initial condition is, let's see, I was trying to think of what f at 0 is equal to 3. I was trying to think of what the function letter was as elf. Alright. Alright, this is ln. Automatically ln. Okay. Just so you know again that you can just do this without thinking. If I had a dy over y plus 9, this is just equal to, if I take that, this is ln of y plus 9, like that, plus c of course, but just to get that. Now if I had again something like 2y, you would have to put a 1/2 in front of that, so like that. Alright, so anyway, that's the idea of that. I just want to, if you just got a single y like that, that's ln on that side. Okay, and if you'd like for me to do another video on that, I'll be more than happy to do so. Okay, x squared, we know that that's going to be x cubed over 3 plus c. This means nothing if you do not add the plus c to this, okay? You miss everything from here on down if you do not do this. At this point now, I'm just going to plug in f at 0. Now x is 0, y is 3. So this is ln of 3 minus 1 is 0 cubed over 3 plus c. Well, we know what 0 cubed over 3 plus c is. It's just c, isn't it? Because 0 cubed is 0 and 0 over 3 is 0. So this is just c. And this is ln of 2. Alright, now I can plug this. I know what c is. It's ln of 2. So now I have this is equal to ln of y minus 1 is equal to x cubed over 3 plus ln of 2. You have the equation, but I believe it's asking you to solve for y. Now, how do we solve for y when there is clearly an ln in front of this? What gets rid of ln? That's right, e does. So we're going to have it right here. Now, I don't know if I'm going to have room on this side to finish, but anyway, we're going to try it. E ln of y minus 1, okay, is equal to, now you have to introduce it to both sides, e to the x cubed over 3 plus ln 2. And that's all one quantity there. Alright, e to the ln, what's that going to bring us to? Y minus 1, correct. Y minus 1 is equal to, now, we come to this part right here. E to the a plus b, what is that? Yes, it's e to the a, e to the b. Alright, you've got to remember that rule. So this is e to the x cubed over 3, e to the ln 2. Alright. A little more cleaning up. What do you see that we can do now to kind of clean this equation up a little more? Yeah, e to the ln is, that's gone, isn't it? So y minus 1 is e x cubed over 3 times 2, isn't it? E ln a is just a, right? Okay. So now I can add 1 to both sides. Okay, so adding 1 to both sides, I get y is equal to, I'm going to put that 2 in front. Alright, so 2e to the x cubed over 3, and then plus 1. There it is. I came up with my general equation. Alright, some people put the 1 plus in front of that. Some people put a 1/3 there. That still counts as 1/3. Either way you look at it, you have your answer right there. Okay. So the idea is, first you got to be able to separate the variables. Okay, you got to get the y, dy with y and x with dx. The second thing you have to do is take the antiderivative of both sides. This side is clearly ln. Okay, this side is x cubed over 3. Then, once I get there, I can start plugging in the numbers. I think on the answer, if you were to look at that, they go a little bit further into that, but again, you do not need to, that's not necessary to go that far and introduce E at this point. I wouldn't. Once I got down to this, I would just plug in the numbers here, and now I know ln of 2 is C. Plug that in right there. You generally have your problem, but they want you to solve for Y. So to do that, you have to understand, to get rid of ln, you just introduce that E. They want to see if you can do that. They want to see if you know what this property here means, and that you can just simply put those two together like this, okay, and then just finally write out the final answer. And by the way, if you want to say alpha at x, that's what y is, 2e to the x cubed over 3 plus 1. Alright, there it is. Alright, that is what we call a particular solution right there. And you always seem to hear a particular solution when you are dealing with separation of variables. Okay. Alright, well that's all I have for this problem, and I'm not going to do anything more. I'm trying to make my videos a little bit shorter. Well, for one thing, attention span for anybody, and I'm talking about myself, well, I don't have much of an attention span, so, you know, and so I know how I am. Now, you may have a long attention span, and that's okay, that's good for you. You do need it when you're studying calculus. You need to pay real close attention to detail. Alright, well anyway, this is KP the Math G, just about ready to sign off. Make sure if you haven't subscribed that you will go ahead and do that. If you would like to make a comment about this lesson, please make a comment. Please do so. If you want to hit that like button, that's always encouraging. Just please, I mean, you might just want to let me know if I'm doing well or if there's something that I could improve upon. Sometimes it may be something, I notice that when I look at this top portion is, this light is right here, okay, and I can't help it. My room space is very limited here, so sometimes I have a glare, and then maybe there's something, if you have a suggestion on how I could stop that glare, maybe you can do that. But anyway, any way that I can help you, or you can help me be better, so I can help you do this better. Alright, this is KP the Math G signing off. Have a great day.